Hello everyone. Today we are going to present about vulnerability for Cisco IOS remote code execution. We would like to start giving you some overview information and risk assessment about this vulnerability. In the beginning, we would like to give you general information about this vulnerability. Actually, the attacker can remotely exploit this vulnerability by establishing telnet connection and sending cluster management protocol (SMB) command to the cluster switch. And you're gonna see more information in the technical part in this presentation. So what's gonna happen if the attacker successfully do his or her attack? So if the exploit works successfully, the attacker can run arbitrary code remotely, which give the attacker full control of the switch. And if it's not working, simply the switch will be reload. Actually, this type of attack affect more than 300 clusters switch, and these are the model that can be affected by this attack. So for the impact, actually it's gonna impact any company that use any of these switches, and the effect gonna be for any device or user hooked up with these switches. Let's say there is a server that run website, so it's gonna be affected. Even if we look like by reloading the switch, only the reloading, not just we don't say about the controlling of the switch, just for the reloading, it's gonna cost the company a serious amount of money. And the reason for that is the out of service that gonna be happen.
Now we're going to move on to the consequences of this attack. The consequences associated with this attack include switches being reloaded, which would essentially cause a denial of service, taking the switch down entirely and losing connectivity until the switch would finish reloading. The execution of arbitrary code with elevated privileges would essentially allow the attacker to gain full control of the device. Now we're going to be going over the importance of these consequences from a business standpoint. Imagine a corporation with a large subnet, and within that subnet there are switches that are vulnerable to this attack. The attacker can cause a denial of service to the entire network, causing a disruption or suspension of the business operations as a whole. All of the switches on a large subnet can be reloaded just by executing one piece of Python code. If the attacker were to remotely execute code with elevated privileges, they can send many types of malicious code to gain access to the switch entirely, erasing configurations, or even worse, set up like a spanning tree loop to break the entire network. The company could potentially lose clients, money, data, and transmission, and even more. Now we'll be going over the cause of this vulnerability. The vulnerability is due to the combination of two factors. The first one being CMP-specific telnet options do not transfer signals and commands internally. The device will fail to restrict the use of CMP-specific telnet options, as they should only be internal local communications between cluster devices. Instead, the devices accept and process over any telnet connection to the affected device. The second factor is the incorrect processing of malformed CMP-specific telnet options. An attacker could exploit this vulnerability by sending malformed CMP-specific telnet options while establishing a telnet connection with the vulnerable switch configured to accept telnet connections. Vulnerable switches will process CMP-specific telnet options by default, even if no cluster configuration commands are present on the device configuration.
So now we will cover a technical discussion specifically about the exploit itself that is made for this CMP remote codec vulnerability. The code can be found on ExploitDB or directly within Metasploit itself. It's simple to use and you will see a demonstration of it shortly. I've also included a reference to the exploit at the bottom, but first, to know a bit more about the code, we can see directly from the creator's comments, this is a buffer overflow. And before we can go ahead and analyze the exploit itself, let's cover what a buffer overflow is. A buffer is a sequential section of memory. Basically, it's the space designated to hold a certain value that can be anything such as strings, integers, array of integers, etc. A buffer overflow occurs when more data is entered in a fixed length buffer than the buffer can hold. So what does that mean? It means, well, if a software programmer makes a mistake and does not handle these situations correctly, we as an attacker can get the code to crash, perform abnormally, or even execute arbitrary code ourselves. And with that, let's look at how the CMP exploit is vulnerable to a buffer overflow. Basically, Cisco's clustered switches perform as one big switch. And to do that, they need a protocol, CMP, to send control and signal messages. To exchange this CMP message, what they use is a protocol called Telnet. And Telnet is used internally, so one of their assumptions was you don't need authentication for CMP Telnet communication because, again, it's internal. And what they did from a firmware perspective is flagged all telnet traffic that's CMP with a CMP identifier. We can see a sample of this code in the bottom right screen. I don't know how legible it really is for you, but you can see a text version of it as well. And basically, there is a section where you have a bunch of variables you can input, and what the creator of the exploit did is they analyzed the traffic and saw that a lot of these variables, specifically the second string variable in the code, was left empty. And when we looked at the code, found that there's no actual check for destination boundaries between the colons to prevent the code from going over the buffer stack. And there is where our buffer overflow can occur. And what that would allow us to do was put arbitrary code right in there and get full access to the system, if anything. We were limited by this feature called data and instruction cache enablement. What this does is, in essence, it creates a cached version of the instruction sets and compares them with instructions being fed. And if they don't match, it'll prevent the new code from being run. What a workaround to this is, well, why not just use existing code already in the firmware to get to do what we actually want to do? And in our case, that's simply convince the firmware that the remote telnet session that we are providing the switch with is actually CMP internal communication. Now, here's a snippet of the actual code from the exploit. And, well, we won't go over all the details, and 4 slides back I did provide, again, the reference to the code that you can go view yourself. But what we'll cover is what's going on, and which is basically we're using pointers to redirect to the correct options that we want to structure our telnet frame. And some of the things we do is, for example, in line 53, we set the flag to identify this telnet traffic as is cluster mode, which is the identifier that says this is CMP traffic, treated as internal telnet traffic, and it's for the master-slave relationship between Cisco switches. Next, in line 70, you can also see we set the privilege level to 15. That's the highest privilege level in iOS, and what that would allow us to do is basically run any command we want from our telnet session to these switches, and again, the iOS would believe that this is CMP internal traffic, and we have the privilege level 15, so we can run basically all the different Cisco commands that exist. Now, one thing we have to consider with this is these buffer overflow attacks are very specific to the firmware, and specifically in our case where the payload is basically just using different pointers to point to different parts of the code and different settings. Any little deviation in the firmware and the situation can cause the switch to perform abnormally, and you'll kind of see that in our demo as well, where we weren't fully able to get a remote session going. But overall scenarios are when you have remote access to the Cisco switches, or at worst you can crash or reboot the switch itself, which again from an attacker perspective is still a win. Last thing we're going to cover is remediation. Initially, and actually for a long time even after the initial release of the exploit, the only remediation to this attack was to disable Telnet for remote access. Once you had Telnet access enabled, this attack couldn't be stopped. Now Cisco has again adjusted the firmware and released free security patches for the exploit that can be found at this link that I provided. But we as a group still think it's best practice to just disable Telnet remotely anyways. You don't need an unsecure, clear communication method wherein there's something such as SSH that already exists for your remote sessions. And with that, we will complete the technical discussion and move on to the demonstration.
So this is going to be our demo for the Cisco Vault 7 exploit that was leaked. I'm going to talk a little bit about our setup before we get into the actual demo. So I have a Cisco Catalyst 2960 switch, which you can see on the left-hand side in the Minicom terminal. It's configured with a static IP on a management VLAN. And then my computer is configured on the same IP range so that it can have connectivity. So it's just going to show a little bit of that right now. So you can see the actual, we just have, show the running config here. So it's just running iOS 12.2. So you can see that we have one port, gigabit 0.1, or 0/1, which is what my computer is connected to, and it's assigned to the VLAN 99. And then my computer, his IP address is 172.16.1.2, so it can communicate. That's one of the things that you have to have. So we can check and make sure that I can ping just, there we are. You can ping the actual switch itself. So part of the thing with this exploit is the switch actually does have to have a interface that it can connect to. So you can see that I can access it via Telnet. I do have to log in, but now what I can do is I can actually run the exploit. So you can see the Python exploit here at my current directory. So it takes two flags, set and unset. Set actually runs the exploit, unset removes the exploit. So in this case, we specify the IP, we set, and you can see a couple flags being changed, and now the switch is actually rebooting. So that's all that we have for this specific demo. This demo does actually have a Metasploit, or sorry, this exploit does actually have a Metasploit module, so you can think of this as like a mass DDoS. You can send this across a whole subnet and take down every single switch, or actually the whole purpose of this exploit is remote code execution. Generally these flags will actually change the telnet so you have unauthenticated privilege 15 access to the switch via telnet. Unfortunately, we didn't have access to any switch that was running the proper version, so the flags or the registers didn't actually have the effect that needed, but it does cause a crash. So that's what we can demonstrate to you today. I hope this is informative, and thank you.